Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA and your host on the Clinker Factor. And today I'm talking to Alex Hall, CEO of Concrete.ai. Alex, welcome. Please introduce yourself and explain how you got involved in the concrete industry.
Well, thank you, Ian. Good afternoon to you. It's not afternoon here, that's for sure. So I guess a bit of my background, always been interested in construction. My father in particular was involved in property development, and that went to university, did a construction management degree, got into the construction world, and then quickly established that I didn't like hopping around the really remote parts of Southern Africa. So with some very good fortune, was introduced to a company which was a subsidiary of what is now Holcim in 1999, and had a variety of roles with them, which ultimately culminated in me being transferred to the United States in 2007, mainly focused on the aggregate and ready-mix side of the business. I was very fortunate to do a stint on the safety side as well, for both the cement and aggregate businesses. And then my last role with Holcim was in charge of the ready-mix performance group in the US. And through that, I actually had my introduction into what was the initial establishment of this company through the University of California in Los Angeles.
And can you explain a little bit about Concrete.ai and the background of Concrete.ai, what it is that you're trying to achieve?
Absolutely. So really importantly, Concrete.ai was formed, the company was only recently incorporated in 2021, but the genesis for the idea actually occurred around 2015, 2016. I was introduced to a guy at University of California, Professor Gaurav Sant. He was busy working on a related but different project at the time. It was called CO2 upcycling. So it was really one of the first projects that was focused on carbon removal. And this is really, it eventually morphed into a company I'm sure you're familiar with, which is Carbon Built. And the premise behind that is effectively the sequestering of CO2 through the addition of Portlandite into concrete block. Really great idea. We really were following that pretty intensely. And as a result, my introduction to Gaurav happened that way. And we started talking about, what the potential applications of artificial intelligence could be in concrete. Fast forward, I actually left Holcim in 2017, but managed to stay involved with UCLA with my new employer, which was actually a construction company, a very forward-thinking construction company out of Boston called Suffolk. They actually remained part of a consortium at UCLA called Transcend. And we kept on seeing all these really interesting innovations that were coming out of the university, and specifically the development of how the use of artificial intelligence could really benefit concrete producers in multiple different ways. And eventually I was made the offer to join the company. And so I joined Concrete.ai in 2021. The real underlying premise behind Concrete.ai is looking at the fundamental building blocks of concrete. So looking at each individual raw material ingredient, the cement, the aggregate, the sand, chemical admixtures, and then obviously the supplementary cementitious materials as well. Getting a deep understanding of both the physical and chemical characteristics, and then really importantly, the environmental impact characteristics as well, which typically manifests itself in the form of the global warming potential. So in other words, the amount of embodied carbon. And then what we're able to do is take that data, actually harvest it from existing software modules that producers have, feed it into our models, and then are able to effectively give back to the client an optimized mix design with some suggested changes from original reference mixes that either allow them to optimize the cost of their concrete, or very importantly, optimize the embodied carbon footprint of the concrete.
So when you started out, did you have in mind that most clients would want cost optimization, and then as time has progressed over the last couple of years, that's shifted towards minimizing carbon?
Well, I think, importantly, the business has spun out of the Institute of Carbon Management. So the long-term goal, the long-term focus has always been, look, we need to be ready for a paradigm shift, if you want, a pivot to more of a way of thinking about carbon in the economy. And specifically when it comes to ready mix, we know concrete's the most ubiquitous material in the world after water. However many, I think the last count was close to 35 billion tons of the stuff is produced every year. And again, cement, the most important ingredient from a cost perspective, but also from an environmental impact perspective. How do we use this technology and embrace it to actually address the amount of CO2 impact we're going to have on the planet? So that's always been an underlying feature. I think one of the reasons Gaurav and I agreed on the strategy that we needed to use was that, certainly in the United States, the ready mix business is very, very competitive compared to in most other parts of the world. It's highly fragmented. Even the large multinational players have relatively small market shares. And as a consequence of that, EBITDA margins are pretty low. I mean, for any business where you're working that hard to have very high single-digit EBITDA margins typically, and then you can imagine if you own the fleet, EBITs are way down at 5%. So in my opinion, if we couldn't demonstrate economic value immediately to a producer, it was going to be very hard to say, oh, there's a potential revenue stream or revenue opportunity from low carbon concrete at some point in the future. So yes, absolutely. The initial driver is fundamentally about cost and cost reduction, but there's also a very strong bent towards the carbon side. That being said, what we've seen is in reality, our kind of go-to-market strategy is now expanding. Well, it's had to expand beyond ready mix. And in fact, our first commercial contract is with a data center owner. They build, operate, and own data centers. And their ask from the get-go was, give me the lowest embodied CO2 concrete.
And why are they asking for that? I mean, what is it that's driving their requirement for low carbon?
Well, I mean, I don't think this is speculative because there's some, for example, if you have a look at a company like Meta, the parent company of Facebook, they've actually done some work recently in Illinois with a company called Ozinga Ready Mix. And I think fundamentally this is where all big companies that have got net zero ambitions and specifically companies that have got net zero ambitions that are relatively short order. Facebook has a net zero, for example, of 2030. And part of their commitment as well has been the scope 3 emissions. So when you're looking at, legacy assets that have got many, many, many tons of concrete embodied with embodied carbon, as you can imagine, that represents, in some cases, tens, potentially hundreds of thousands of tons. When the time comes that one has to pay the piper and your science-based initiatives get down to, all right, here is day zero, or whatever it is, January 1st of 2030 or December 31st, at some point you've got to pay the piper. And the reality is that even with renewable energy use for 1 and 2 on the on the production and maintenance side of things, at some point you're probably going to have to buy removal credits. Removal credits are pretty scary. One of the companies I'm involved with actually has a purchase agreement where removal credits are purchased at $260 a ton. But I can cite articles in Reuters that showed removal credits at the end of 22 approaching, they were north of $1,300 a ton. So this is one of the challenges, is that the removals are going to be one of the mechanisms that these companies have to look at. So that being the case, it makes a whole lot of sense now to try and reduce your load today from an embodied CO2 perspective. But then the reality also is from a cost perspective, you could probably take some kind of a cost premium today, and that is certainly going to be massively offset by whatever the impact of net zero target dates are going to be.
Yeah, it's interesting you mentioned scope 3, because I think we see an increase in scope 3 reporting. All of it to date, I think, is voluntary, but it's happening more and more. Companies are setting targets, including scope 3. And I think some of the companies have probably set their scope 3 targets without perhaps realizing just how big their Scope 3 emissions are. I was talking to a house builder last year, and they were very surprised at the impact that including Scope 3 had in multiplying their emissions by 100, because, of course, most of it is in the materials or in the usage of the homes. And I think this is, as companies set targets and realize what they're going to need to do, it's going to drive demand and hopefully innovation as well. And talking about innovation, you're normally based in California, but I see today that you're not in California, you're in Las Vegas. So what takes you to Las Vegas, Alex?
Other than the mandatory couple of nights out here, one of the reasons we have, the first and foremost, it was the National Ready Mix Association's annual general meeting. We're one of the members of their services group, really important organization within the United States. But also, you may be able to see a number of really interesting displays outside. Though that's actually a very, very large construction expo called ConExpo. One of the biggest in the world, and a great opportunity to see all new technologies. But the primary reason for us being here is that we were actually awarded the Innovation of the Year prize by the National Ready Mix Association for our optimization software.
Well, congratulations for that award. And what does that mean to you in practice?
Well, I think a lot of it is validation for the methodology that we've approached. We used as our approach. For an industry body that represents the majority of producers in the United States, and the US produces in excess of 300,000 cubic meters a year, over 400,000 cubic yards. It means a lot to us because in order to get that recognition, we also had to be able to demonstrate there's a commercial viability to the product, but also that it can have a meaningful impact environmentally as well. And so with our beyond our initial pilot, some of the original commercial mixes that we put into play ended up having pretty significant reductions from an embodied CO2 perspective, in fact, north of 20%. And the interesting part with that is the technology is such that it actually uses some techniques that humans typically would, but obviously we are able to do hundreds of thousands of transactions in the same amount of time that a human would typically do one or two. But it still allows humans to apply judgment to a situation, and rather than just say, oh well, the AI is always right. It's not always right. That's not the case. You are always going to need a human to interface with the software and say, yes, this makes sense, this doesn't. The AI designs a new mix design in what are considered optimal conditions, but you can imagine that on January the 4th in Chicago, it was negative 16 degrees Celsius. So what do you do then? You can't use exactly the same mix design. So that's where the human judgment component comes into it. And for us, it's really interesting because it's almost more of it's kind of algorithmic business thinking, where the human can actually engage with the artificial intelligence and apply judgment, which is something AI can't do.
Yeah, I think ChatGPT has shown us that AI is not always right. Impressive though it is in many ways.
Absolutely.
And this topic of the interface between the operator or the human and the AI system is one that I think comes up repeatedly in different applications of AI, and clearly is one of the keys to making the technology effective, if you like, in its deployment. I wonder if we just look at the source of demand for the future. We hear a lot about the IRA over here, and it's clear that it's had a big impact already on electric vehicles. Is it having an impact in your area in construction and concrete?
Yeah, well, interestingly enough, that's actually the kind of third go-to-market strategy. We've been approached by some large multinational construction companies that have subsidiaries in the US with focus typically on infrastructure, wastewater treatment works, roads, that kind of stuff. And the way the IRA has been structured is, they've typical kind of federal document. There's all sorts of different elements and components that are going to be applicable to different parts of the businesses. But certainly in their case, they very clearly have requirements to ensure that in order to meet some of the scope mandates from a embodied carbon perspective on building materials, they're going to have to find alternate mechanisms in order not just to secure the bid, but to qualify for the bid as well. There are definitely a few challenges out there. One of them being whether or not items like cement or aggregate are actually even going to be applicable for this, which is kind of crazy because, how much steel is made in the US versus how much cement is manufactured. There's north of 110 million tons produced in the US last year, plus imports, so these are truly products that are made in America and really should be considered as, part of something that's applicable to the Act. And very clearly, in terms of consumption, the federal and state governments consume a lot of these building products in the US, and why not take the opportunity to maximize the impact as a consequence?
Yeah, so I think this is one of the things that has been clearly a potential everywhere in the world is for government procurement to encourage change within the cement and concrete industries. And the question is, what's the most effective way of doing that? So what you're seeing here is a requirement for to meet some low carbon criteria in order to qualify for the project. Is that how it works?
Yeah, that's correct. And what's another thing that's really interesting is for example, the EPA have earmarked $250 million for the advancement and development of EPD documentation to effectively act as the base unit of measure to ensure compliance with it. So it's definitely a holistic approach from sort of a federal level to come in and see this mechanism being put in place to actually measure A, efficacy, but B, the actual result in terms of are people doing this. It's one thing to be able to measure, but it's actually then putting the measurements in place at a contractual level and validating that these targets are actually being met on a contract by contract basis. Now, I honestly, I'm a little bit wary of this. I think we saw this in 2008, 2009 when TARP came out. One of the challenges is going to be shovel-ready projects, and so it's going to be really difficult to convert existing infrastructure projects to meet these criteria. But I think what you will see is that this will become part of an expectation going forward, with elements of these specifications being written into contract documentation. So long term, it has to have an impact. And one of the things that the National Ready Mix Association, for example, are already heavily focused on is the conversion of mixed design specifications from prescriptive specifications with fixed ratios, sometimes fixed volumes of cement, to more performance-based specification. And I think this is definitely going to be one of the mechanisms that gets used to push that.
So I think in the UK, in the precast area, it's very much focused on concrete performance specifications.
Right.
But still in the ready mix, it's a recipe, or a composition based specification. And is there a difference in the US between the way it's treated in ready mix and precast?
Oh yeah. I think so, and I think even if I again a bit of a plug for the Institute of Carbon Management here. One of our sister companies is a spin out of ICM. It's called Carbon Built, and for example, they're actually on the way to commercialization right now, and their technology is such that they can actually sequestrate some CO2 into these block products. That kind of opportunity certainly does not exist in the ready mix world at this point in time. So you're actually seeing the movement towards that kind of stuff happening in the precast world. And yes, absolutely, the ready mix is certainly pretty prescriptive, especially at state and federal level. So if you're working with any of the DOTs or the FAA, for example, these are really, really typically heavily prescriptive mixes, and in many cases significantly over designed from a performance perspective. And again, we're able to demonstrate that both quantitatively and qualitatively, using our software.
If you look at the kinds of recommendations that your software is recommending,
yeah.
Are there some particular sort of characteristics that you see in terms of it recommending change in cementitious or change in aggregate particle size or this sort of thing?
Yeah, so it's really interesting from a global warming potential perspective. Purely speaking, a lot of this is determined by geography, and I need to qualify that, because typically it's the availability of a product like fly ash that is going to make the biggest difference from a substitution perspective. In comparison to fly ash, the global warming, in comparison to cement, for example, even an IL cement, the GWP of fly ash is negligible. Slagment does require processing. So, let's just use a round number for cement. Let's say it's, 800 kilograms per ton CO2. Slag's around the 120 mark, and fly ash as being a waste product is way, way, way down, in some cases below 15 that we've seen reported. So again, one of the realities in the US is in some areas it's cost prohibitive to have pulverized fly ash from coal-fired power stations. Forget it on the West Coast. And so what we're starting to see is more of a preponderance of the natural fly ashes coming out, specifically out of Utah and Northern California, and those actually provide real opportunities. That being said, one of the interesting things when you start really digging into the results that the software generates has been the impact of aggregate. Now, it kind of makes sense that would be the case, both by mass and by volume. Aggregate is by far the biggest constituent in concrete, even though cement is typically 40% of the cost. And what we've actually been able to see is in areas where cement substitution is literally not available. There's just no product available. Aggregate changes and moving to higher quality aggregates with less water demand, etc., can have still a pretty significant impact. I mean, in the Bay Area, for example, we've seen cost reductions in the order of 5-6% just with changes to aggregate constituents. So again, it really is all about geography. The quick win in the concrete world has typically been with fly ash substitution. As you can imagine, in the US, with a lot less energy being generated by coal, we're not seeing as many of those opportunities anymore. But what we are seeing is people getting back into fly ash reclamation from many of the old coal-fired power stations. That is certainly going to be an industry that does pick up. Obviously the Germans don't have that problem. They seem to be bringing a lot more coal online, and they've probably got a lot more fly ash. So good luck to them.
Yeah, well, I think not only fly ash, of course, but there's also a lot of old slag stockpiles.
Absolutely.
In North America and Europe, and people looking at ways of doing that. We had a company called Material Evolution on the podcast a few weeks ago, and they're looking at slag, at a very old slag stockpile in Teesside. I think it was 100 million tons or something like that, that accumulated over God knows how many years up there. But they were looking at a geopolymer mix. Is that something you're starting to see people being interested in?
Not really. I think just to be really clear, one of the realities is this is a pretty sold out market. I mean, we're under a lot of pressure from a supply perspective, and a lot of the clients that we're dealing with, even at this point in time, have got upwards of 80% of their order book secured for the year, which is counterintuitive because we also do know the construction cycle can tend to lag, so that may really be the case. A lot of our clients are really just focused on trying to get the product out, and experimentation like that, it does take a bit of time. We certainly seeing that kind of stuff happening at the universities. Universities are absolutely looking to start working towards that stuff. But from a commercial perspective, there are a handful of producers that are doing that, but I wouldn't exactly call it mainstream at this point in time.
Right. And are there other trends that you're picking up that you think will affect the concrete business, say, in the next 5 years?
Oh, certainly. I mean, I even just on this trade show and seeing some of the admixture suppliers and some of the products they're bringing online. I mean, I'm not going to name any names, but there's some guys out there that are really cutting edge with some significant products, both on the actual chemical admixture reduction side, and then using admixtures to reutilize return materials as well, which was actually quite an interesting one for us to see, because we got to try and get ahead of the game in terms of data collection and understanding what the impact of that is going to be. But very, very interesting to see what's happening on the admixture side of the business. hopefully we're going to have an announcement in the near future about a partnership we're trying to develop with one of the admixture suppliers. But yeah, it's pretty fascinating to see what's happening on the chemical side.
Well, good, and I think that's an excellent upbeat note on which to conclude, Alex. So thank you very much for joining me today.
Oh, absolutely. Thanks for the time and appreciate this, Ian.